The first launch of the Starship Super Heavy was both a success and a failure. The success was that the rocket itself did much more than Elon wanted and cleared the tower easily without blowing up. But in the process, it virtually destroyed the launch pad, which maybe was what Elon actually feared might stop it from clearing the tower. Judging by the damage that the 15-odd million pounds of thrust, if you factor in the 3 engines not running, did to the pad, it's hard to believe that no one at SpaceX didn't expect something like this to happen, even though the static fire test led them to false expectations. SpaceX has a large number of ex-NASA personnel, and they will have been well aware of the power of the Super Heavy was well beyond that of the capabilities of the Boca Chica site, even more so with a very limited water deluge system and no flame trench. Now many are saying that it doesn't matter and it was never more than a test to prove the whole thing would get off the ground, and that the damage can be easily repaired. But if they are to progress anywhere near to what they aspire to do, then they must have a proper launch pad that is capable of handling what is effectively the equivalent of 2 Saturn V's strapped together again and again and again at intervals of maybe days or less without major damage. NASA launched 12 Saturn V's, 82 space shuttles from Pad 39A over 56 years without any substantial damage. So what can SpaceX learn from NASA and hopefully do it quicker, cheaper and better? A big thanks go out to Brilliant for sponsoring this video. SpaceX are going to be on one heck of a learning curve to sort out the launch pad. They have chosen to go a different route to the tried and trusted methods that NASA have used for 50 years of launching the heaviest, most powerful rockets. Time will tell if they can do this, and time is the one thing they are short of, and I'm sure they'll be doing an awful lot of computer modelling. However, if you're looking to learn new skills in math and computer science and time is also important to you, Brilliant.org is the way to learn interactively by breaking down complex problems into smaller ones that are easier to understand, not only for students, but for professionals looking to get a quick grasp on new skills. Brilliant has loads of courses and thousands of lessons, but for things like computer modelling that SpaceX will be doing, you need Computer Science Foundations, a 3-part course that shows you the fundamentals of how computers and programming work. Once you've completed that, you can move on to things like algorithms and then on to neural networks, and this will give you a good basic understanding of computing in today's modern environments. And that's not all. You can learn math and science from basic to advanced, all at your own pace and time on PCs or mobile devices. Get started now, and the first 200 people will get 20% off of the annual premium subscription if you use the link brilliant.org/CuriousDroid shown here and in the description below. Whether or not debris thrown up from the launch pad at SpaceX's Boca Chica location was the actual cause of the Starship's ultimate demise is still a matter of conjecture that we might not know the full answer to for some time to come. However, what is not in doubt is the damage the thrust did to the concrete launch pad. Also keep in mind that this was a normal launch, without any anomalies or explosions on the pad. If they were to do the launch again tomorrow with a new rocket and a new pad with the same design, then the same thing would happen again. If you watch the launch, you can see that at about 6 seconds just after the rocket starts to lift off the pad, several huge pieces of what look like reinforced concrete, each at least several meters in size, are blown up alongside the rocket to a height of probably 150 meters or so. Another view shows splashes in the sea just beyond the Boca Chica beach, as dozens of large pieces of concrete are blasted up to 500 meters from the launch pad. But because there's no flame trench to guide the exhaust, there was nothing to stop that debris from being ejected to the same distance in every direction. Footage from cameras which were outside the gate to the facility about 215 meters from the pad show a shower of concrete and debris raining down and hitting a camera car before they engulfed in a huge dust cloud. That dust and sand started raining down on the surrounding area up to 6 miles or 10 kilometers from the pad within about 10 minutes of the launch. Just looking at the amount of concrete in sizes ranging from pebbles to meter-plus size boulders that were blown up from the pad at probably near supersonic speeds, it seems inconceivable that none of that hit the rocket in some form or another, and possibly resulted in not only immediate damage to some of the engines, but also to the small explosion and flames seen just above the main engines at T plus 29 seconds and T plus 33 seconds into the launch, and the shutdown of more engines slightly later. Why this happened is yet to be determined, but the Super Heavy booster did a static fire test in February 2023, which ran 31 of the 33 engines for about 7 seconds at about 50% power, generating about 7.9 million pounds of thrust, which is a little higher than a Saturn V, which made 7.5 million pounds. It's unknown if any damage occurred during the static fire test that weakened the heat-resistant high-strength concrete known as Fondag, which was used to make the base of the launch pad. If the concrete pad was compromised, then when the full power launch occurred, it could have shattered it rather than worn it away abrasively. Once the concrete started to break up, the extreme thrust would have made its way through the cracks to lift it from beneath, and once part of it was lifted away, the rest would follow. Once that was out of the way, then there was nothing to stop it from digging up the earth and sand beneath. SpaceX said they had been working on a method that could have mitigated this 3 months or so ago. This is a massive double-layer water-cooled steel plate that would cover the launch pad area and could be kept cool enough for long enough to survive the launch. However, it was deemed better to get the first launch out of the way as soon as possible, as the metal pad wasn't going to be ready in time. This would also need either a large pumping station or a large water tower to supply enough water to keep it cool enough for long enough. For whatever reason, SpaceX seems to have concentrated on the rocket whilst treating the launch pad as an afterthought in order to get the test done, but it has come back to bite them in the backside big time. So how has NASA been able to handle what were the largest rocket launches ever made for the last 50 plus years up until the advent of Starship, with only minor damage to the mobile launch pad on the SLS launch and almost no issues prior to that? Well, one thing that both SpaceX and NASA facilities share is that they are both next to the sea on land, which is just above sea level with a very high water table, making digging out the ground to make a flame trench very difficult and expensive, but it's not the only way to do it. Back in 1961, the missile site and launch site for the Mercury and Gemini missions, which was then called Cape Kennedy, was chosen to be the launch site for the Apollo missions, and the largest rockets ever built at the time was Saturn V. In total, NASA acquired 141,336 acres of additional land for the launch facilities. Even though the Saturn was going to be rated at 7.5 million pounds of thrust, they planned for the possible use of rockets like the Nova and thrusts of 5 times that amount, or up to 35 million pounds of thrust, as well as nuclear-powered rockets, both of which never came to fruition during or after the Apollo missions. But now big rockets are back on the agenda with the 17 million pound thrust Starship. Because of the large amount of fuel that was carried by the Saturn, it was calculated that if it did blow up on the launch pad, it would have the equivalent explosive power of about 450 tons of TNT, about the same as a small battlefield tactical nuclear weapon, or about half that blew up the port of Beirut in 2020. So each of the launch pads had to have a clear radius of 3.5 miles or 5.6 kilometers around them, which is why the launch pad 39A and B are at that distance from the vehicle assembly building. When NASA acquired the land where pads 39A and B would be placed, it was a mixture of marshland or partially submerged at the intersection of the Banana and Indian rivers. The main thing that NASA wanted was a flame trench to divert and control the exhaust from the Saturn rockets at liftoff. This would direct it in a northeasterly direction towards the Atlantic Ocean and also divert some of the shock waves away from the other nearby structures and fuel tanks as well as the rocket itself. However, because the ground was just above sea level or just below it, the water table was also very high. This meant that if the launch pad was to be at ground level, then the flame trench would have to be dug out of the ground to a depth of over 50 feet or 15 metres. Keeping water out would then become very difficult and very expensive. So they decided to raise the whole launch pad and build the flame trench under it at ground level. They dredged up 3.76 million cubic metres of fill from the Banana River to fill the submerged areas, and at the launch pad sites, they built up truncated pyramids on what was Merritt Island to a height of 80 feet or 24 metres. This was left for several months to allow it to compress the soil underneath and make it stable. After it had settled about 4 feet or 1.2 metres, they removed the top part of this giant sand pile to bring it to a height of 55 metres or 16 feet for pad 39B and 44 feet or 12 metres for pad 39A. The flame trench bisected the launch pad and had an inverted V steel flame deflector directly under the hard stand where the rocket would be. This would deflect the exhaust down the high temperature brick-lined concrete chute and away from the rocket. The flame trench was 490 feet or 149 metres long, 58 feet or 17.6 metres wide, and 42 feet or 12 metres deep. To cool the flame deflector, a water tower with a capacity of 94,000 litres held enough water to provide a flow rate of 188,000 litres per minute for 30 seconds. A second system provided cooling for the flame trench and another for the pad cooling and sound and shockwave reduction. This is how NASA did it, and it took them 3 years to build and a lot of money, but the result has stood the test of time. The problem SpaceX faces is that they are using a rocket with twice the power of a Saturn, so maybe even the existing NASA pads might need some upgrading. In 2014, SpaceX signed a 20-year lease for the exclusive use of Pad 39A from NASA for launches of a Falcon 9, Falcon Heavy and Dragon 2 space capsule for the eventual transportation of crews to the International Space Station. In 2020, they started building what was almost a copy of the Starship Boca Chica launch pad, about 300 metres east of the main launch pad 39A. Elon has said that they would like to launch all the NASA Artemis 3 missions from the NASA facilities. But with the performance of the pad at Boca Chica, NASA is less than happy at the thought of the same thing happening at Pad 39A, as any damage could seriously impact the already busy launch schedule. They could in theory use the original NASA pad for Starship, but because it has a different tower and requirements, the Falcon would have to be moved elsewhere, possibly to where the spaceship pad is being built now, or to another existing smaller pad elsewhere at the NASA site, adding more time and money to an already very tight schedule. So back to Boca Chica. The addition of the water-cooled pad may well save the pad from the damage we saw before, but without some form of flame diverter or better water deluge system, they still run the risk of further damage, not just from the exhaust, but from the acoustic shockwaves this creates, which can resonate with the body of the rocket and the engines, causing further unforeseen problems. This is why they had the massive water deluge sound suppression systems installed at the NASA Pad 39A in the days of the shuttle and beyond, because the acoustic shockwaves from the engines could cause damage to the shuttle's payload. At the moment, the exhaust at Boca Chica just spreads out in every direction, which may be fine if they have some other form of deflector system, but any they choose must be able to withstand as many launches as possible without major rebuilding works on a regular basis. Building a raised NASA-style pad may well do the job, but it will be prohibitive from both a cost and time perspective. It could mean a major change at Boca Chica, and apparently a few years back SpaceX did apply to the Army Corps of Engineers to build such a pad, but because of issues in satisfying the ecological requirements to allow dredging and pumping of what could be millions of tons of fill to build a raised launch pad near protected wildlife areas, the application lapsed and as far as we know hasn't been reapplied for. After the last launch, the FAA will be mandating many changes as well as enforcing mitigation strategies to reduce the ecological impact of the launches, and these will force SpaceX to consider its launch pad much more than it has gotten away with so far. The tank farm alone is only 100 metres from the pad, which took a hammering from the last launch. At pad 39A, the original equivalent tank farm is 370 metres from the main pad and much lower in height. Whether they can keep this at such a close distance remains to be seen, but it just looks like another problem that they will have to eventually deal with. SpaceX have said that eventually they want to be able to launch Starships several times a day to bring the cost per launch to maybe just 10 million instead of the 100 million plus it is now. But for that, they will have to have pads which are even more reliable than the NASA ones. And this could pose as big an issue as developing the rocket itself if they don't sort something out soon.